Hi, my name is Donald EA. In today's calculus class, we're gonna introduce an idea called implicit derivative. Before we start implicit derivative, we're gonna do some review of derivative, or we say explicit derivative. Sorry. Let's say we're gonna say derivative of 2x. Okay, we know that you're gonna get 2. Okay, so that's really simple and easy. Let's say d to the dx for the x squared. That's just going to get you 2x. Because of power rule, you drop down the 2 in the front and you subtract by the 1 on the power. So that's going to get you an answer of 2x. Now, let's do the same derivative, but implicit. We call it implicit derivative. Implicit derivative just mainly something that you need to memorize is there's a chain rule always. Here, let's say d to the dx at a 2x. Okay, so we know derivative of 2x that we're gonna get 2. Okay, now we gotta do derivative of x respect to x. So in that sense, we just multiply the in. That's one easy way to look at. Okay. So that's just gonna get dx over dx. X derivative with respect to x. So there's always a chain rule. You're gonna do respect to x, and you're gonna do derivative of x. Okay. So in this term, is we know anything over anything, as long as there's anything is the same, then you cross out, you can get 2. Now, how about x to the second? We're gonna do power rule, which is we're gonna do outside first, the power rule first, which is 2x. Okay. Now we need to do derivative toward the x, which is like a chain rule. What people tend to forget is this part. So let's do derivative of x respect to dx, d to the dx. So you're gonna get dx over dx. Okay, so you not only do a derivative of this, you also do a derivative of x. So you're always gonna get 1. So be 2x times 1. Okay, same thing if today is y. Okay, so let's do derivative of y. That's just gonna get you 1 multiplied by derivative of y respect to x. That's just gonna be dy dx. And that's the key thing we always looking for, dy dx. Every time you see a y and you do it with respect to x, you're gonna get dy dx. Okay, so that's one thing that you want to remember is every time you have a y, you're gonna get dy dx. Okay, so let's just say today we start out with y squared, or y to the cube. Let's say y to the cube, d to the dx. Okay, we're gonna do power rule first. We drop down to 3, and the y. Now the power is gonna subtract 1 by 1, which is 3 minus 1. Okay, now after you finish this, you gotta remember, don't forget, do the derivative of y, because we only do derivative of y to the cube, and we take it down. We do normally we do a derivative. Now every time you're doing that, after that you have to do derivative of y. So you just multiply y in, so it's be like, you look like this, dy dx. Okay, so that's the answer. It will be 3y to the second dy dx. Okay, let's say we do derivative of x y to the second. Okay, now people need to remember is this is a product rule. What I mean by product, it just means there is a multiplication between x and y to the second. And when there's multiplication, that means product rule, okay, with two different variables. Now let's say d to the dx on this. Product rule, you do derivative of the first one term, which is 1, okay, times y squared, okay, plus we leave the first term alone, which is x, okay, times the power rule again, 2y. Is that the answer? Okay, that's not the answer. We forget about something. We only derivative of y to the second, but we forgot to derivative of y. So here you're gonna get dy dx. Okay, so that is your answer. Okay, y squared plus x times 2y dy dx. Now let's do this. D to the dx of sine y squared. Okay, that is gonna get you, remember you gotta do derivative of sine first, which is cosine of y squared. Okay, it's like a chain rule, so you need to start with the outside, the outermost, which is sine. Then you're gonna leave what's inside alone and don't do anything yet. Now you're gonna do derivative of what's inside, so you're gonna get multiplied by 2y. Now only that's 1 to the second power. We haven't do derivative of y yet. Okay, so let's memorize this. Dy dx. Do a derivative of y respect to x. So this is what people tend to forget. Oh, when I was doing calculus, I always tend to forget this term. I do everything else, but I forget about this term. So that's the answer. Now here for this equation here, d to the dx, y equal to x squared, 2x squared plus 2. Here we're going to do derivative of that. Okay, so that's just going to get you dy dx, because y times by d to the dx, that's going to get dy dx equal, on the other side it will be 4x, because of the power rule, using it will be 4x. Now 2 derivative of 2 is equal to 0, everybody knows. Now why do we do implicit derivative? Sometimes when we're doing derivative, which is most of the time, the reason why we're doing derivative is to finding the slope. So we need to recognize we're looking for dy dx. Okay, that's equal to what? Dy dx equal to f prime of x, which is we know as a derivative. Now all the equations look like this: y equal to something. Sometimes the term could be y to the cube, y to the second, x squared, y to the cube, combination of x and y, or y to the multiple power, or sine of y squared, a function, and within the function there's y. It's impossible to solve all this equation explicitly. okay, you have to do an implicit derivative, which is finding dy dx. So to answer that is a function with x and y mixed together, or y to the multiple powers. Okay, now before we do this, I just want to make sure everybody copy this down so I can erase it. Okay, so let's erase it. So a function of x and y mixed together, for example, yx squared plus 2y equal to 3x squared plus sine y. This is a perfect example like why we need to do derivative implicitly. Okay, now this is part one. The next part we're going to go to the examples of the implicit derivative. Okay, thank you.